Okay, let's get started with the chapter 8.1 homework. This is going to be 8.1, 8.2, and 8.3. This problem I did earlier and I removed it. Okay, so I did this problem earlier too, but we'll go ahead and do a similar problem. Okay, so if you watch the video for hypothesis tests, we have to set up a null and alternative based off that claim. So go ahead and pause and read the question and come back. Okay, so the mean pulse of adults is equal to. So they're giving you a claim. That's the claim. And mean is mu. And they said is an equal sign. And they say that's 69.3. Okay, so if the claim is an equal, the alternative will be an equal. And it's going to be the same as the claim. Remember, the claim's not what actually happens in the sample. The claim is what they think is true in the population. Now I'm looking for direction here. Do they think it's different than that? Or I don't see anything there, so it'll be a not equal to. The problem, if it wanted direction, it'd say something like, hey, we think it's greater or we think it's less than. If they don't say any of that stuff, and it's just going to be a not equal to. So our job now is to take a sample, 68.9. That's somewhat different than that, but not too much. But the sample size is pretty big. I think they have us do this test a little later. Oh, that was 8.1. No, sorry, we're on 8.1. Okay, so 8.3. Okay, most adults would erase their personal data. Okay, so most adults is basically saying that your alternative would be that it's equal to 0.5. Most would be greater than 0.5. Okay, so to find the test statistic, and there is a formula for this, but we're just going to go ahead and run it on statcrunch. To find the test statistic, you just run a prop stat. So over here, stat, and then proportion stat, one sample. If you watch the videos, this is actually part of 8.2. Okay, so the number of successes would be, it'd be 65% of 442. So I'm going to bring my calculator up and show you how to find that. To find out how many successes there are, we have to take the 65% of 442. So 442, let me get out of the screen. $442 times 0.65. So 287. And the observations was 442. And this sets at 0.5. This is saying, oh, this should be a greater than sign. Right there. Greater than should match that. Greater than because it says most adults. Most adults would be more than half. And our test statistic is a z-score, which is 6 point, what do they want? 2 decimals? So 6.28. This should work. Okay, that's our test statistic. There is a formula, and I won't go into the formula. Okay, now it says fewer. So fewer is going to go in your alternative. And fewer is a less than sign. That's a less than sign. 0.94. So your alternative would be that it is 0.94. Now it's going to be important that you guys are stopping and reading these questions first. Okay, so they took a poll of 1,002 and 88%, that's p hat, said they have a cell phone. Find the test statistic. Okay, so let me just show you what the test statistic's measuring. If you watch a video, it's there too, but I'll just remind you. So this is technically not their claim. This is their claim right here. But if they make this claim, we have to set it equal to 94, so then we have some expectation. Well, they get 88%. Well, 88% is over here somewhere. So we need to figure out how many z-scores this is. So the formula to do this by hand would be 0.88 minus 0.94 divided by the standard deviation of 0.94, 1 minus 0.94, all over how many we sampled. This is what statcrunch is doing, but you're fine just doing statcrunch. So remember, this is a prop stat, proportion stat. I need my mouse. Okay, stat, proportion stat, one sample summary. Okay, now again we need to find out how many successes. It's 88% of 102, which is going to be close to 880. So 1,002, that's how many people we surveyed, and 88% of those. So we have to do times 0.88. And I'm going to go with 882 out of the 1,002. Now we need to change this to a 0.94, and we need to change this to a less than sign. Now 8.2 will get you real good at these things. So this is just kind of showing you how to do them. Okay, so negative 7 point, that takes that higher. I'm going to go negative 0.800. Hopefully that works. Okay, that 4 stays. Take that to a 7. Actually, I'll take that back and I'll do 7.97. Yeah, this would be better. Okay, another test statistic problem. But this test statistic is going to be a different test. A different statcrunch button. So let's do the claim. The mean is equal to 69, and then they took a sample, and it was 68.1, and the standard deviation was 11.4. This guy's going to tell you which button to push. If you make sure you go back and watch the videos to determine which one it's going to be. It's going to be a t-stat. So to find the test statistic, we have to hit t-stat. We have one sample. We don't have data, but we have the summary of the data. The sample mean was 68.1. The sample standard deviation is 11.4. And the sample size was 156. Our hypothesis, let me write that down. It's going to be 69. And the alternative, I'm looking for direction. And they don't give me direction, so it's a not equal to. So is it equal to 69? Or over here, the alternative, is it not equal to 69? Okay, and our test statistic is the t-stat right here. So we need it. Okay, that's not working, so we'll just stick with the negative 0.99. Okay, so the way that these tests work is this way right here. So they're going to do a test. Your alternative, or sorry, your null is p equals to 0.4. Now they don't tell me that, but they tell me the alternative. So you obtain testing the claim. If you ever get a claim that's a greater or less than, that's going to go in the alternative. So this makes this a right-tailed test. So what's going to happen is this is going to be 0.4. Now they take a sample and they get something over here. And they tell us that this z-score is 1.47. So these are p-hats right here. So we're going to switch to z-scores. Now the nice thing about z-scores is the mean is 0 and the standard deviation is 1. And they tell us 1.47. And since this is a greater than, it's a right-tailed test. So I need to find that shade right there, which we've done in chapter 6. This is called the p-value. And to find that, we use the normal calculator. Now I explain this all on the lesson videos also. So if you need to go back and review those, you could review those. So this is going to be the normal calculator. And then see the 0 and the 1, that means we're in z-scores, which is the z-score that they gave us. We'll change this to a greater than sign because we're on the right side, and 1.47. 1.47, and here's our answer. We have to go, okay, so let's just answer this question. It's a right-tailed test. And our p-value is, we have to go 3 decimals, 0.071. So that's how you do that one. Okay, so what should we do with this p-value in an alpha of 1%? So if this is totally new to you, you guys have to go back and watch the videos. I did all these on the I talked about these concepts. But if the p-value, which is 0.071, you have to compare that to 0.1. So if this is bigger, then you're going to fail to reject the null. Okay, so it's either going to be A or it's going to be that one. So whenever you fail to reject, it's always we do not have sufficient evidence. So it's going to be A. Okay, so this is almost the same thing. Okay, so look at this. The claim is that it's a not equal to. So when you set up these things, you want to get good at setting these nulls up. So the null is always an equal sign. They actually gave us the claims and the alternative in this case. So this is a two-sided test. Now the p-values to the outside of the z, to the extreme of the z. But since this is two-sided, you have to go to negative 2.1 also. Just doubles the shade on the side, on the extremes. So this is two-sided, or two-tailed. Now to find the p-value, I'm just going to change this to a 2.71. Okay, now that's this part right here. So this part right here, look over here, is this part. Okay, so we also have to do the same thing to the other side. So what we need to do is we need to double that value. So we need to put in 0.0033. So what we need to do is put this value in here and times it by 2. Now timesing it by 2, it just multiplies this by 2, which means it adds these two together. So that's going to be your p-value. We have to round to 3 decimals, so 0.007. Now, when you run this test using statcrunch, like a t-test or a z-test or a propstat, it doubles it for you. Okay, so now what we have to do is we have to compare. We have to compare our p-value 0.007 with our alpha. This step will get you good at for next semester, or sorry, for next section. If the p-value is less than alpha, then we're going to reject the null. If the p is low, the null must go. So it's either going to be C or D. And if I reject the null, I had it written up there, but my null was p equals to 0.358. Now I'm rejecting that. So if I'm rejecting that, I'm taking the alternative, which is right there. So we should have evidence. There's sufficient support to claim. Yes. If I'm rejecting that it's equal, then that means I have enough evidence to support that it's not equal. It should be logical. Essentially, everything we're doing now is just getting you set up to do the tests in the next section. Okay, so less than 59%. So that means your null hypothesis is that it's equal to 0.59%. And your alternative is where the less comes in. Now they take a sample. Oh, they got a p-value. Good. So the p-value is large. This is large. So if the p-value is high, the null will fly. So this is going to fly. So we're not going to reject this. So this should be a fail to reject because the p-value is greater than. Now if you fail to reject, let's see where this guy. Now we didn't reject this, so that means we didn't have sufficient evidence that's less than 59. That's how it works. We didn't have evidence for this. So C, read C. You should always pause too before I give you the answer. Pause and see if you guys can get the answer. So if we're not rejecting the 59%, if we're not rejecting that it is 59%, then we can't support that it's less than 59%. Okay. Now here's your p-value, which is super low, super small. So since it's small, we're going to reject H null. So what they're saying is that in a certain region, they think that the mean pulse rate is 69. So the alternative, the thing that if that wouldn't be true, then it must be different than 69. So we have a low p-value, which means that we're going to reject this. Well, if we reject this, that means we're taking that to be true. Well, we think this is true. So we're going to reject because the p-value is less than alpha. So that's straightforward. It's your decision maker. And remember, I'm rejecting the 69. So if I'm rejecting that the average is 69, that must mean I have sufficient evidence that it's different than that. There is sufficient evidence to warrant rejection of claim post rate. There is sufficient evidence to reject. Okay, and last one, Dropbox. Okay, so it looks like okay, so if you want to establish success We would want a low p-value. Okay, so if there's several methods to increase the likelihood of having a baby, they do a clinical trial. So the alternative is that it's greater. So the null, it's going to be equal. So if they want this thing, they want to show that it's greater. So to show that it's greater, you want to reject. Let me just write this out. So your null hypothesis is point equals 0.5, and your alternative is that it's greater. Now, if you worked at a company and you want to say that you have a better chance of having a girl, then you would support this and not this. So we want to reject this. So if you want to reject this, we want the smallest p-value possible. The smallest p-value will reject this. Well, if this gets rejected, then this is your alternative, must be effective. Okay, so that's how that works. Okay, let's go on to the next one. In the next section, 8.2, is basically just doing the tests. Okay, here we go. 8.2. Okay, let's get started. Okay, so go ahead and pause and go ahead and read the problem. Okay, so whenever I'm trying to determine if it's a left tail test or right tail test, I'm trying to set up my null and my alternative. So okay, their claim is that less than 11%. So that's going to be your alternative. That less percentage of people treatment will get headaches. So they don't want people getting headaches. So right now it's 11%. If they give this drug, they want it to be less than 11%. And there it is right there. So this is a left-tailed test because this is a less than. Less than falls on the left. Okay, what's the test statistic? So to get the test statistic, we have to run the test. Now, this is going to be a proportions are always prop stats. Or sorry, they ran the test for us. They ran the test. The test statistic is the z-score right here. So it's 0.01. 0.01. I'm taking this number right here. If you look up here in this box over here, I'm taking this right here. Over here. I'm trying to see if I could get like a laser pointer on this. Okay, let's see. Okay, the p-value is this guy right here, 0.5. 0.5048. You could have went ahead and ran this test, but it's gonna, as a props test in statcrunch, but it'll give you the same thing. Okay, what is the null hypothesis? The null hypothesis is this one right here. Okay, now this p-value is large, so that p-value is larger than that significance level, so we're going to fail to reject. Because the p-value is greater than the significance level. What that means, there's not sufficient evidence that less than 11%. Whenever you reject, that's evidence. Whenever you fail to reject, that's not evidence for the H1. think I'm going to switch to this one. There's not sufficient evidence to support the claim that less than 11%. There you go. It's the last one. Okay, so in a study, go ahead and pause the video and see if you could set up a null and alternative. Okay, so they did this study and it says test the claim that most medical malpractice lawsuits are dropped. Most are dropped. Okay, so if since it says most, that's going to be a greater in the alternative. So in the alternative, I'm looking for a greater. So that's the only greater one. So that's it right there. Okay, now to find the test statistic, we have to run the test. This is a prop stat. Okay, number of successes was 509. The number of observations was how many they studied, which was 796. And this needs to be a greater than. And the test statistic is going to pop up as a z-score. Z-stat, 7.2 decimals, 7.87. And if I'm going too fast, you guys could just rewind and do it all again. Okay, the p-value is the p-value. Since it's less than that, you could just put 0. If you round this to 3, 1, 2, 3, you could just put 0 there. Okay, so a p-value is 0 means that's less than this 1%, so we're going to be rejecting the null. See, this is your p-value is 0. That's your significance. 0 is less than this. So the result they got from their sample, this p-hat was way out of the ordinary. It's not something they'd expect if the null was true, so we're going to reject the null. Okay, so there is sufficient evidence to support the claim. Yep, that's true. See, we're rejecting the p equals 0.5 and going with the p is greater than 0.5. Okay, random sample. Okay, so the claim is that it's 50.5% newborn babies are boys. So that's going to be your null hypothesis because it's an equal. Okay, your alternative is going to be a not equal to. Because nowhere does it say something about greater or less than. I usually like writing these steps out. Okay, the test statistic. We're going to go ahead and just hit options, edit, and just change it from here. Okay, so there was 428 boys. And they had 864 births. Okay, my alternative should be 0.505. And my alternative should be a not equal to. Once you change it up here, this automatically changes. My test statistic is this one right here. Let me try a mouse, maybe that'll work better. This is how I usually do it. For whatever reason, it's like coming out of here for some reason. So how many decimals? -2 decimals, -0.57. Okay, the p-value, 0.5713. And I'll do 0.57 1 because this is 3 decimals. Okay, so now we have to do this whole p-value thing. So this is a very large p-value. When you compare this p-value to 1%, this is way bigger. So this should be a fail to reject. There is not sufficient evidence. Once you get used to it, it's like the same thing over and over again. Okay. Okay, so we failed to reject. So since we failed to reject, it does support this 0.505, but the reason it wasn't because there's no evidence to say that it's untrue. This is wrong. I'm going to go with the last one. This is probably a more true way of saying it. The results do not support this. It just doesn't say that it's not this. It's kind of confusing. Okay. Let's go to another one. So this is a polygraph. 24 cases were wrong out of 74, and 74 were correct. And it says correct less than 80% of the time. So what's the chance it's correct less than 80% of the time? That's going to be your alternative. Your null is going to be that it is correct 80% of the time. So it's correct 80%, less than 80%. If the claims ever are less than or greater than or not equal to, then that's going to go into your alternative. Oh, I just selected the wrong one. Sorry. It's a less than. Less than 80. There we go. Okay, so options. Edit. So I'm looking, let's start with observations. So how many times did we test this thing? 98 times. Out of those 98, how many times was it correct? That was 74. And if you want to see how that compares to 80%, you could always do that and just do 74 divided by 80. This is the sample result. So the sample result was 92.5%. That seems a lot bigger than this. Okay, that's going to be our next step. Oh, no, we're on Z now. So Z, let's finish this up. That's going to be 0.8. And that should be a less than. That the tested claim that are correct less than it. Well, they were correct over 80% of the time. This is going to be a big p-value, really big p-value. No. Maybe I read the number wrong. Oh, it was 74 out of 98. That was my problem. I'm glad I went back and did that. Okay, that's 75.5%. We're testing that. So my sample result fell less than that. So is this enough evidence to say that it's less than 80%? Okay, good. That makes much more sense. My p-value is test statistic negative 1.11. Okay, p-value 0.1332. Okay, so let's do this. Identify the null alternative. Okay, correct conclusion. So to make the conclusion, we have to compare this 13% to their 1%, and that's going to be a fail to reject. And that's just not sufficient evidence. Okay, so the known alternative. So claims is equal to 21. So their claim is that it's equal to, so that's going to go into your null hypothesis, which is your H0. So it's either going to be one of these three, and nowhere does it say less than or greater than, so it's going to be a two-sided, two-tailed test. Okay, so this is where I'm putting my sample data. The observations would be how many candies that we looked at, and that was 100. And then this would be how many candies of them were blue. Well, 25% of 100 is 25. If you didn't know, you could just do 100 times 0.25. Okay, my alternative is 21, or 0.21. And then my null is 0.21. My alternative is a not equal to, as you can see here. This needs to match here. This is your sample results. And compute, we have 0.98. So our sample result was about 1 standard deviation away. Okay, the p-value is 0.326. And 0.326 is very large. 1%, this is another fail to reject. There is not sufficient evidence to warrant claim. Okay. Another treat nausea. They had 54 patients develop nausea out of this. More than 20%. So I think it's more than 20%. So the claims are more than. So there's a more than. It's greater than. It's this one. So if their claims are greater than, it's going to go on your alternative, which makes your no always equal. Okay, so we need to run the data. Now remember, every time here, I'm hitting prop stat. One sample and summary. Successes would be how many successes, which was 54. Observations is how many subjects there were altogether, 233. So all I'm doing is matching this up with this when I run my test. Okay, so I got a z-stat, which is your test statistic at 1.21. I got an alternative, p-value 3.113. Okay, 0.113 compared to an alpha of 5%. This value, this p-value is bigger than this value, so that's going to be a fail to reject and not sufficient evidence to warrant support for more than 20. Okay, that most people would be bigger than 50%. It would be that one. That's most people. If it's not most people, it's 50%. Okay, so now we need to run the test. They had 64% say yes out of this many people. Okay, the number of observations is 21877. Now this is going to be out of those people, how many said yes? Not what percent said yes, how many said yes. So you do that, you do 21877 times 0.64, and then you just round to your nearest whole. So 14,001 14,001. People said yes. Remember, sometimes you don't have to do this. Sometimes you have to do this. They just give it to you. Sometimes you have to do it if they give you a percent. Okay, so this is 0.64. And this would be most people. Sorry, this is 0.5. And most people would be greater. So this needs to match this. And I get 41. That's a really big test statistic. 41. P-value is going to be 0. I don't even need to look. If you're 41 standard deviations away, there's no shade more to that. Okay, 0 is less than 0.01, so we're going to reject. There is enough support for the most, because we're rejecting the equal. We're rejecting this right here. Well, if this gets rejected, then we think this is true. Okay, so since they let the people from the internet do it, it's definitely not valid if they just let these people do it. I like D the best, but maybe A. Oh, it's D. Okay, and last one for this chapter. Favor or response. Okay, exclude the 125. Favor is equal to 50%. Favor is equal to 50%. Favor is equal to 50%. And they exclude the 125. Okay, so to run this test, we're not going to take those 125 that we're unsure. We are going to take the people who favored and the people who opposed. So the total responses was 489. Those who favored plus the 395 who didn't favor. So that's 884. Okay, now how many people favored it? 489. And this needs to be a not equal to, because that's a not equal to. And the reason that's a not equal to is because the claim says equal. So I have the equal here, and if that's not true, it must be not equal. Okay, 3.16. Okay, p-value is going to be 0.002. 0.002. That's over here. I just rounded to the third. And what should we do? Where's my... I'm looking for my significance level. Okay, 10% significance level. And I get a p-value of 0.002. So 0.002 is definitely less than that significance level. So we should be rejecting. Whenever we reject, we have evidence to reject the null and find evidence for the alternative. Okay, so we rejected the null. They were randomly selected. So it's either going to be B or C. I'm looking at the claim now, up here in the problem. So we rejected that it was 50%. So they're wrong to claim that they were equivalent to a coin toss. Let me go back and show you that again. So they think it's equivalent to a coin toss, which would be 50%. Okay, so we just rejected the 50%, so they're wrong to think that it's equivalent to a coin toss. Okay, so let's jump to let's jump to the next one, which is 8.3. Okay, so the last one. I don't want to take a test or a quiz, homework. Okay, 8 problems here. You definitely want to watch a video on this one because this one has a couple different buttons. 8.2 is all prop stat. These are about means. Okay, so they got this n equals 93. They took a sample. Make sure you pause and read the question and come back to it. Okay, so they have a claim that the mean is equal to 4.25. If that's their claim, then HO should have that as an equal, which would be A, B, or C. Okay, and the alternative will be a not equal to because they don't have a greater or less than anywhere in the problem. Okay, so now to do this problem, we have to figure out what buttons to push. And the way you could tell that is by looking at this right here. It's either this or sigma. Sigma is the SD of all in the population. This is the SD of the sample. So they took 93 people and found the standard deviation of those 93 people. Those 93 people are not the population, they're the sample. So this is going to be a T-stat. Usually means are probably a little bit easier. Okay, so now we just match up, or we have a sample mean of 4.16. We have a sample standard deviation of 0.65. And a sample size of 93. Okay, my null is 4.25. And my alternative is a not equal to. So we're all set. This is going to be a T. Okay, so I rounded this to 2 decimals. That 4 rounds that 5 rounds that 3 to a 4. The p-value is going to be the same thing, same place, 0.185. Perfect, and everything's going to be the same. I mean, it's going to be able to reject or fail to reject. It's the same idea as from last section. So what we want to do is we want to look at this and compare that to this. Is that greater or less than? That is greater than. So this should be a fail to reject. And whenever you fail to reject, you do not have sufficient evidence to conclude. So conclude that the original claim Okay, so let's see if this makes sense. There is not sufficient evidence to conclude that the original claim, let's look at the original claim. Okay, good. That last one's a little tricky. It's worded a little weird. Okay, so here's another one. This is about data speed. So they sampled 186. They sampled 186. They got a sample speed of 685 with a standard deviation of 2.15. Alpha's 0.1. Okay, now let's see what their claim is. There's their claim right here that the population mean is less than 7. So less than 7 and 7. So it's going to be D. Less than 7 and 7. Okay, now we have to run the test. This one I'm going to click the button, stat. I'm like, okay, is this a Z or a T-stats? And this is a T-stats because we're using S. Okay, we're going to go to a summary. Sample mean, 6.85. Standard deviation, 2.15. Sample size, 186. Okay, a null is 7 and alternative is a less than. And we get negative 0.95. Okay, good. P-value. P-value is 0.171. Okay, so same thing. We compare this p-value, follow me up here, to this 10%. 17% is bigger than 10%, so it's going to be a fail to reject. There is not sufficient evidence to conclude that the mean of the population is less than. Okay, we couldn't find evidence for this because we believe it's 7. That's the normal way it's written. The first one was a little tricky. Okay, and the test effect of lowering garlic. So they got 64 subjects. The test. They measured the cholesterols before and after. And the mean was 0.1. And the standard deviation was 2.13. The changes before minus after. Okay, so before minus after, so they went down about this much. They went down about 0.1. Okay, use a file to test the claim that the mean change should be greater than 0. The mean change could be greater than 0. So they gave you a claim that should be greater than. So that's your alternative. That's your greater than. Okay, now we have to run the test. And as we did before, I'm going to run through the whole way for these. So stat, and then you're going to go to t-test. You're going to do one sample and then summary. Summary just means they gave you the average. The average, people went down 0.1. But everybody didn't go down 0.1, so there's some spread in the decreases and the increases. The sample size was 64. 0, and this needs to be a greater because it says the claim is a greater. See right over here. And this will give me the t, point. So what do we have to round it to? So 0.38. Okay, determine the p-value. 0.354. Okay, so same thing. Our final conclusion, we need to take this p-value and compare it to our significance level, or alpha. which is 5%. That's 35%. It's definitely bigger than 5%, so we should fail to reject again. Whenever you fail to reject, there's not sufficient evidence to conclude that the mean changes greater than is greater. We couldn't find evidence for this one right here. Okay, I did this same exact problem in the video, so you guys can watch that from the video. Okay, let's see here. They're measuring the lead levels, some traditional medicines. Claim that the mean is less than. So the claim is that it's less than. So if the claim is that it's less than, that needs to go in your alternative. And your null would be that it's equal to 16. Okay, so now to do this one, since they gave us data, and I don't want to put the data over here, we'll just go ahead and open up the data in here. Okay, so now the data is open there. Now notice we do not have sigma. We don't have any standard deviation at all, so they're going to have to figure out the standard deviation for us, which makes us use the t-stat. And in this case, we have the data, so you're going to just click data. Okay, I have my data in variable 1 over here. This should match part A. So 16, and is the lead level less than 16? And that's it. Compute, it'll run the test. So negative 2.07. Okay, 2 decimals, so 2.1. Negative 2. Sorry, I put it in wrong. That's better. Okay, p-value is just this guy right over here, 0.0341. And 3 decimals would be that. Okay, so for this one, I'll just take a little more time with it. This is my p-value. And then my significance level is 0.1. So this is your p-value, that's your alpha. You have to compare your p-value to your alpha. If your p-value is less than alpha, we're going to reject H null. So we're rejecting this. So if I reject that, that must mean that I believe this. So I'm going to reject the null. So that must mean there is sufficient evidence that the women lead is less than. See, I believe this. That's why there's sufficient evidence to believe that's less than 16. Okay, another data one. Student estimate the reference time. Test the claim that these are from a population with mean equal to 60. So your mean, this is your claim. If that's your claim, it's going to go in your HO. And your H1 will be that it's different from 60. Okay, so which one's that? Looks like it's that one here. Okay, now to run the test. We do not know the standard deviation of the population. Okay, so we're going to come down here to t-stat. over to one sample. We have data. No, I don't want to do that. Let's just go ahead and open it up here. Either that or I'd have to enter all the data in, but it's just faster to do it that way. Stat, T-stat. We have data. We're going to select which one we want. I have to change my hypotheses to match my hypotheses here. That's a not equal to. That's a not equal to. And this will give me the T in the p-value. So 2.3. And the p-value. .0337. Just checking to make sure on the decimal placement. Sometimes they switch them up on us. Okay, now we look at this. 0.03 compared to the 10%. 0.03 is less than that, so we should be rejecting this null. So I'm rejecting this right here. So if I reject that, I think this is true. So that means I have sufficient evidence to believe that it's not 60. So there is sufficient evidence to conclude that the original claim of paternity is not correct. It does not appear that they're good at it, because I just rejected the 60. Okay, and 2 more to go. Use the pulse rates from the beats per minute from random sample of adult females, blah, 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 less than 60. So they gave you a claim that's less than 76. That goes in your alternative. Once that goes in your alternative, then your null is going to be that's equal. It's always how it works. Okay, now we have to run the test. So we'll go ahead and pull it up in their statcrunch. So here's the data. Open in statcrunch. This is going to be another T-stat because we don't know the population standard deviation. T-stat and one sample data. Select the column with the data and let's match the null and the alternative for our hypotheses. Okay, good. So our test statistic is negative 2.73. And the p-value is 0.004. Okay, so now what I'm going to do is I'm going to compare 0.004 to 5%. And 0.004, the p-value is low, the null must go. So I'm going to reject the null. Okay, now remember I'm rejecting this. So if I reject this, I have sufficient evidence for this. So there is sufficient evidence to conclude that the mean is less than. That's a less than sign. And last one. Okay, 50 earthquakes. What's their claim? Test the claim that the mean greater than 1. So since that's their claim is a greater than, we're going to chuck it in the alternative. So that means the null isn't equal to 1. So I'm looking for that here. It's a good strategy too to always try to do it first. Equals 1, greater than 1. Perfect. Now we need to run the test. We'll run the test off their data. There's a lot in here. They seem to be bigger than 1, but there's some less than 1 in there, so I don't know what it's going to do. Open in statcrunch. So now we want to run a t-test. So it looks like all these are t-tests. Select the variable That's the variable with all the magnitudes in it. If I just move this over a little bit, variable 1 has all the earthquake magnitudes. It says to change to match our known alternative. And you don't have to worry about any of this other stuff, just compute. 2.22. Okay, round to 2 decimal places. P-value 0.016. Okay, let's make sure I'm good there. Okay, now we have to compare this with our alpha of 5%. So this is 1.6%. This is 5%. 1.6% is less than 5%, so we should be rejecting this null. We should be rejecting this null and thinking that's true. There's sufficient the population is greater than 1. Perfect. Read B. It sounds perfect. Oh, so does this one. Oh, there's sufficient evidence. Sorry. These things sounded the same. So there is sufficient evidence. We have evidence that this is true. Okay, good. So that's chapters 8.1, 8.2, and 8.3. I hope this was helpful, and be on the lookout for 9 pretty soon. Thanks for watching.